I'm going to work through a problem like number 22 at 14.7 where we're asked to find the volume between the upper part of a sphere and the upper nape of a cone. And I'm going to give a slightly different problem. I'm going to say our sphere is defined as x squared plus y squared plus z squared is equal to 1. So we have a radius of 1 with the sphere centered at the origin. And our cone is defined as x squared plus y squared is equal to z squared. So, well, let me do a couple of things before I get started on solving the problem. One is I'm going to rewrite this first one using the second equation. I'll get z squared plus z squared is equal to 1. All I did was substitute z in for x plus y. So that means that z is equal to 1 over radical 2 or radical 2 over 2. So this tells me one thing. It tells me where the sphere and the cone intersect. The second thing I want is I want to write z in terms of this first equation. So z squared is equal to 1 minus x squared minus y squared, or z is equal to the square root of 1 minus x squared minus y squared, which is the same as r squared. So I'm going to hold on to these two equations because they're going to come in handy later on. So I have, well, I have this one here, z defined in terms of r, and z defined in terms of where the sphere and the cone intersect. And now let me draw by picture. So I have a sphere of radius 1, and I have a cone that's coming up to meet it at square root of 2 over 2. And I probably didn't need to do this first thing to figure this out, because if I have a radius of 1, then I should know that r is going to be equal to the square root of 2 over 2. And because of the particular triangle I have, a 45-degree triangle, the lower part of z is also going to be equal to that. And I'm interested now, so now I know sort of where we're starting with the cone going up to the top of the sphere, a height of radical 2 over 2. Okay, so now what is the integral I'm going to use to solve this? Well, we're looking for the volume, so I'm going to use a triple integral. I'm going to do it dz, dr, d theta, because having done this problem, I know that this is an order that's going to work out for me. And my function is going to be r. And this is the solution to the problem. It's a pretty easy solution if you think about it. The only thing that isn't so easy is now I need to find the limits of integration. Well, for theta, I know what the limits of integration are, because my cone is going to go all the way around. I'm not going to bother with that. Let's start out with, for r, well, I know a little bit about r, but let me come back to that. What about z? Z is a difficult one. So if I look at this, z is going to go from, so z is going to go, is defined in terms of r here. So z is going to go from r to 1 minus r squared square root. So where am I getting that from? Well, first I'm getting the lower limit is going to be whatever my r happens to be is also going to define what my z is. The second one is that I know that z is equal to 1 minus r squared by my substitution. So this should give me the lower limit of my z up to my upper limit. And let me just check something. When r is equal to 0, I get 1 minus 0 squared, or 1. So that does, in fact, give me the r that I'm interested in at this point. Okay, what about, I'm sorry, the z that I'm interested in this point. Okay. Now, what is my r going to be equal to? Well, I'm sweeping out from 0. I want my r to start at 0 here as I come around, and I'm going to go out to this value. So the biggest I'll be going because of where the cone meets that is square root of 2 over 2. I'll leave you to figure out this last part here. It's just going to be the limits for the theta, the angle around, the angle relative to the z-axis. So this is sort of what the solution to number 22 is going to look like. It's going to be a function r, the vector that we're going to use to sweep out a volume, in terms of z, where we're going to decide where do we start at and how far do we go to pick it up. In terms of r, which tells us how far do we go out here. Well, the furthest I go is going to be dropping down from where they intersect, and how far do I go with theta. Okay, well, I hope this helps you a little bit. At least you could see what the function looks like, and using this, maybe you could piece through and figure out what the upper limits, what the limits of integration are for z, r, and theta in 22.